Hello everyone, this is Himal, Assistant Professor of Assam Downtown University. So today we'll be discussing on a topic on basic principle of MRI. So here we go. So here we have MRI. So the full form of MRI is magnetic resonance imaging. So here the name is magnetic resonance imaging. So if you go to the old history of it, before the name was NMR. So here the full form of NMR is nuclear magnetic resonance. So let's discuss how the name nuclear was gone, because now we call it as magnetic resonance imaging. Before the word nuclear was used, so it was a new instrument for for health. So when people hear the word nuclear, they used to be scared, thinking of dangerous, hamperous, hazardous. So as we know that is MRI is non-ionizing. It's non-ionizing. That means we don't have that impact as if you compare with the ionizing radiation. So this is non-ionizing. So because the nuclear word came, people used to be scared it might be hazardous, but in actually it's not. So today I'll be discussing in such a way that the things will be easier for every one of you to understand, and you can clarify some of your doubts. That's why I'm just doing it in a simpler way. So I think your doubt is clear. Now we are using the word magnetic and resonance is there. So now I think your doubt is clear for nuclear magnetic resonance, and now presently known as magnetic resonance imaging. So let's go into the detail of magnetic resonance imaging. So here the word magnetic, it represents magnet. The word itself, it's discussing. So here we are using magnets. That means magnets means magnetic field. Magnetic field will be used over here. And resonance I'll come into detail about it later when we'll be discussing, when we go further to this topic. And imaging, as you know, that we're gonna do the imaging of all the internal structure. They are very good for soft tissues. So now let's hold on for this. Now let's discuss a bit about the basic principle of MRI, how exactly the things goes on. So now I'll be discussing about water molecules. As we all know that the formula of water is H2O, right? So here we have hydrogen, proton. And now why I took this word, why I took this element separately, there is a reason behind that. Because when you go into the detail of your body, we all know that our body mostly consists of water. So here the water is playing a very important key role in our this MRI imaging technique. Without this, without the proton, and when we discuss about the proton, we are talking about a single proton. We know that atomic number is 1 of hydrogen, right? Whatever elements you take, it should have a lone pair at the end. If you are taking lithium is having 3, right? Atomic number, if it is 3, so what we'll say, because as you know that I think by now you must be knowing about electronic configuration, when you discuss about electronic configuration, sure, see, if it is lithium, we should go, see, 2 1, right? The inner shell will be 2 and the valence shell will be 1. So 1 is the valence shell. This is also another lone pair, right? So we can use any other elements which is having lone pair and in the valence shell, but we are taking hydrogen, as hydrogen is mostly consist, like it is highly present in our body. Okay, by now you might be a bit disturbed or maybe a bit confused, so let me clarify your doubt why we are using or why we are highlighting all these elements. So MRI, right, it is a machine used for imaging. So here the proton is present inside your body because you need to take the images of your body structure, of your body, right, body structure, especially for the internal structure which you can't visualize from the outer surface. The inner surface need to be visualized. That's why we are using MRI, right? So this is the reason why hydrogen, which is highly present inside our body. So now we will be discussing further, highlighting all this protons, which is very important. So I hope this much is clear. So let's flip the page and let's get started with the a bit detailing about this. See, when we talk about hydrogen, right? Hydrogen, it spins. I think, let me show you with the pen. When I talk about spin, means spinning, right? Every one of you might be knowing the meaning of spin. It just spins. But here the things not only spins, it also precedes. Precede means like this. It spins as well as it precedes. See, spinning and precede. When you discuss about the universe, right? The planet it rotates as well as it revolves from the sun, right? Sort of an example you can imagine the planet of the universe, how it goes, right? They rotate as well as revolve. So here the term spin is spinning of the proton and it precedes as well, right? So this is what spin and precision, right? But why I am discussing about this, suppose this is a proton, I'm giving this arrow, right, showing that it's spinning, right? But let me show about this. Imagine this as like it is, you know, processing. So it, you know, it gives a shape of a corn like this, right? Obviously in the middle it will be the axis, right? So it spins as well as presses. But why we are discussing, so let me clarify your doubt now. Spin and precision will help you to, you know, discuss more about the detailing of the proton. Anything which let me give you the example. If a current pass through a conductor, if a current pass through a conductor, what happens? It flows through the conductor, but then there will always be a magnetic field around the charge, right, around the conductor through which charge is flowing. So that is the magnetic field. That means if the charges flows, there will always be a magnetic field around its area, right? So the same with the body. As our body, suppose this is a human body, assume this as human body. Let me use another pen to show you the proton. Suppose this is your proton. Proton is present everywhere inside your body. Suppose this is the head, this is the head, everywhere, right? Hydrogen, proton you will find everywhere inside your body. But see the direction, it is like in a random motion. It's not that I'm doing it randomly. There is a purpose about this which I'll be discussing. So here I think your doubt is clear about this, right? A single proton, it spins as well as it precise, right? Or precise, whatever, however you pronounce. But when you go about the detail about your body structure, inside your body there will be hydrogen proton. So this hydrogen proton, it is spinning as well as precessing inside your body, but in a random motion in here when your body is outside the magnetic field. I think till here, I think you got the idea about hydrogen proton, right? So let me show you the another thing. Next, the principle of MRI, where we have these steps. Okay, so we have 5 steps. Okay, for basic principle of MRI. For basic principle of MRI. Fine. So first step, you have to learn this properly because it is in a short form, but it will be very helpful. The first thing is body inside the magnetic field. Second one is body outside the magnetic field. Number 3, RF pulse switch off. Fourth one is RF pulse switch on. And the final one is signal collection. But in the bracket I'll give you key space. You'll be learning this later. So these are the 5 main important points about on basic principle of MRI. So let's discuss about the first step, body inside the magnetic field. So when you are going for MRI, what happens? So I'll be explaining now. When your body, I have just flipped the points. Let's start with this first, then second will be this, because body outside the magnetic field, what happens? The first draw diagram which I show, this one. Can you see here the proton? They are randomly directed. That means they are in a random direction. Why? This is what exactly happens. In first step, when your body is outside the magnetic field, let me draw here. I'll write in short, when body is outside the magnetic field, right? What happens? Suppose this is your body, and let me change the color with this. It's in random motion. Can you see? It's in random motion. This is what when your body is outside the magnetic field. And when your body is inside the magnetic field, let me show you now. When your body is inside the magnetic field, in short form I'm giving. What happens when your body is inside the magnetic field? See here, this is your body. So now see the proton. Can you see? Can you see now the arrangement? It is directed parallel or anti-parallel. But can you see the lower number is directing towards the anti-parallel direction? But in the parallel direction you'll find majority of the proton. Can you understand a bit? So let's start. This what happens when your body is placed inside the magnet or the MRI machine. When your body is inside the MRI machine, what happened? All the proton which was in the random motion will be aligned either in parallel or anti-parallel. The best example which I can give is, if you are in the classroom but your teacher has not yet arrived, you'll be sitting randomly wherever you want. You will go with your friend to chat, right, to talk and all. But the moment your teacher comes, what happens? You will sit according to you. That means it will be aligned, right? Everything will be aligned. So that's what is happening here, the alignment. So this is the alignment, but can you see majority is directing on the top, but not top. I'll use the word parallel, and the low number is an anti-parallel direction. The best example which I can give you is like, all of us know how to walk with our foot, right? But some people are there in this planet who can even walk with their hand upside down, right? You must have seen that. So this is what is happening now. See, random motion, now again align, parallel and anti-parallel. Majority is in parallel direction because like it doesn't require much energy, but this requires much energy. That's why very low number is directing towards the anti-parallel direction. Now fine. Okay, now what happens is like, see, here we have 4, here we have 3, right? It's just like an example showing that majority numbers doesn't mean that it doesn't count in this way. It is like in a huge numbers. So what happens? This the parallel and anti-parallel, which will pull each other. So see, they paired, parallel and anti-parallel, they paired, right? But only the single out here is left. What will happen to this? Both of them, they will fight, they will pull each other, right? Parallel and anti-parallel, they're gonna pull each other and it will get demagnetized. So which one is remaining? Only the single one, right? So this one will remain, so because he didn't get anyone to fight. So now what will happen is this. Now whatever you want to show will be this proton. Now it's in parallel direction, right? So this is the second step. Now let's come to the third step, right? See, we have completed body outside the magnetic field, body inside the magnetic field. Now let's go with the RF pulse. You might be confused with the name RF, the short form RF, pulse switch off. So when you talk about RF, the full form is radio frequency pulse. It is radio frequency pulse. So what happened? Your body is, see, till now we have not yet started the procedure. It's just you're placing the body inside the machine and things are happening. All this happens before giving RF pulse. Now the main strength, the main magnetic field will be applied by this RF pulse. So when everything happens, see, this is also known as shimming. Okay, to maintain the homogeneity. Shimming helps in what? It helps in maintaining the homogeneity. Okay, so that's why it's in homo means same, right? That's why it's in the same direction. So let's go to the third step, RF pulse, switch on. See, now your body is placed, everything, the arrangement, whatever to be happen inside your body happened. Shimming done. Now the third step is RF pulse switch on. Now when we start the procedure, and the moment we switch on the RF pulse, this is the radio frequency pulse which will come from the gradient coil which is in the machine, right? That RF pulse will come up, and it will go inside the body. The moment it goes inside the body, see the parallel, I'll draw only the arrow so that it will be easy for you to understand. This direction is showing, magnetization, full magnetization. Right now it's in the parallel direction, so this is also known as longitudinal magnetization, LM, longitudinal magnetization. When you give the RF pulse, right, if RF pulse is coming, and it will strike the, if it will strike your longitudinal magnetization, or simply you can use the word proton, what will happen? It gonna flip. Right now it's in perpendicular direction. The moment RF pulse comes, it will flip, right? So what will happen now? This will flip and it will go towards this direction. That means here separately I'll be showing this is what gonna happen. Longitudinal magnetization, this is known as transverse magnetization, TM, transverse magnetization. Can you understand? This is TM. RF pulse given, see, from the longitudinal magnetization it goes to the transverse magnetization. That means, see, from here it gets flipped, right, when your RF pulse is switch on, and it will be like this, right? So this is the third step. So let's go to the fourth step. I think you remember the fourth step is RF pulse switch off. Fourth step is RF pulse switch off. So what happened? See here, sorry, this page, right? So when you're on, it goes and flip. This is also known as flip angle. This angle, right, is also known as flip angle. RF pulse switch on, it goes to the transverse magnetization. When you off, transverse magnetization will go back to its original state, that is longitudinal magnetization. Can you understand? That means it was here, right? So when you off the RF pulse, it will go back to its original state like this. First one, show the arrow, it goes towards the transverse magnetization, but when you off it, it goes back to its original state, that is longitudinal magnetization. Clear? So that's what happened. So you know what exactly, let's discuss about the resonance. Remember, we stopped here. I told you I'll be explaining later. Resonance. So this what resonance. So resonance is like, when RF pulse comes, because originally you will have your own spin. This proton is spinning and processing, right? The moment you give RF pulse, what happened? The tuning should be there. That means the RF pulse and the tuning of the proton should match. If it doesn't match, the signal won't be getting, right? See how the signal goes. When you switch off, right, the transverse magnetization will go towards the longitudinal magnetization. In between, it passes a signal. I repeat, in between, it passes the signal. And remember the final step, the fifth one, signal collection. Yeah, this is how it happens. This signal will be collected by this K space. Here the signals will be collected, and this collected signal will help you, you know, to form an image. Do you understand? So these are the some steps of the basic principle. Here we also have a bit detail about it, so which we will continue in the next class. Thank you.